Hey everyone, this is Derek, and this is section 8.1, Operations with Rational Expressions. I'm going to start with a review of just basic operations with fractions, because we're going to see these same things with algebra, same exact steps. So a good place to start is just reviewing how to do it with numbers. So for simplifying fractions, we kind of do this thing in our head where we're like, I think we can get rid of a 7, but it's usually a little bit fuzzy for people. So what we're actually doing is we are factoring, we are canceling. So whether we know it or not, we're going 5 times 7 is 35, and 7 times 7 is 49, and then saying, here's a 7 over 7, and 7 divided by 7 equals 1. So that's what's happening when we're reducing fractions, is we're reducing out common factors of 1. What it usually looks like in practice is we go 7 goes into 35 5 times, 7 goes into 49 7 times, and we don't write all this stuff. But this is the math that allows us to do that. And writing it in this format where we're heading is exactly what we're going to need. This idea of something goes into something, cancel, doesn't work as soon as you start looking more like that. So that's simplifying. And then with multiplying, yeah, you are just a pest. Okay. So with multiplying, a lot of times, you're taught to just multiply straight across, which is true, that is multiplying. But then after that, you have some big, horrible fraction, you have to simplify it. So an easier way to do that is like this. And again, I'm going to write out kind of the longer version, and then the same as I did here, I'll show you kind of the shortcut in terms of numbers, but that will not work for where we're going. What I'm showing down here is what we're going to need for the algebra. So what I would do if I was doing this out kind of a little bit more methodically is I'd take this 9 and I would write it as 3 times 3. 21, I can write that as 3 times 7. 10, I can write as 2 times 5. And because this is multiplying, that just basically means we have that, right? The numerator is going to multiply itself, the denominator is going to multiply out. But what I can do now is say, 3 over 3, there's a factor of 1. 5 over 5, there's another factor of 1. And what I'm left with is 7. 3 times 2 would make 6. And so we can also multiplication with fractions is basically factoring and canceling, with multiplying the stuff up at the end. Let me write this a little bit larger down here and just show you another way to write it, just kind of in terms of handwriting, so that you're not having to write out all this for doing numbers. If we're doing algebra, this is exactly what we need. But for just sort of numerical problems, here's a little bit maybe better notation. So here we can usually spot, there's a 5, right? So 5 goes into 5 once, 5 goes into 10 twice. So I just reduced out that common 5. What I'm left with is the same 1 over 2. I'm just writing with a bit of a shorthand. Here we can probably spot the 3s. 3 goes into 9 and 21. So 3 goes into 9 3 times, and 3 goes into 21 7 times. So now I have 1 times 7, there's the 7, 3 times 2, there's the 6. So this might be a little bit cleaner way to write it, but this is, in terms of algebra, again, that's what we're going to want. So if I have 2/5 divided by 3/10, I can rewrite that as 2/5 divided by 10/3. So multiplying by the reciprocal is the same as dividing. A nice way to think of that is if you have, 10 divided by 2, that is 5. If you have 10 times the reciprocal of 2, which is 1/2, what's half of 10? That is also 5. So the reciprocal of the second number is the same as the division. So here I'm just rewriting this as a multiply. And then let's do the thing we had just done earlier. 5 goes into 5 once, 5 goes into 10 twice. And that will leave us 2 times 2 is 4, 1 times 3 is 3. Addition and subtraction are the ones that are a little bit harder. That's where we have to have a common denominator. And once we have that common denominator, then we're free to add the numerators. But it's the idea that if we had 1/5 plus 2/5, what we're saying is we have 1/5 of something plus 2/5 of something, and that gives us 3/5 of something, right? That doesn't work if I say 1/5 plus 1/2. those are not the same size, so I can't add them directly. I have to get a common denominator. So that is what I will do up here. Notice in this problem they gave us this 4/6, which seems sort of silly. I'm going to reduce that and make it 2/3, because I'm going to eventually have to reduce out the 2. If I can see it right there, might as well do it now, because that's a pretty easy spot. So 3s and 10s, so my LCD is going to be 30, so I'm going to multiply this one by 3/3. So I'm making an equivalent fraction. It's going to be 27/30. That is the same thing as 9/10. I'm just giving it a different look so that I can have a common denominator. This side is going to need 10s, so 10/10. And now that gives us 20/30 plus 27/30. So 20/30 plus 27/30, and that will make 47/30. And that doesn't reduce, so we're done. Okay, and so now we're going to do that exact same stuff, but with algebra rather than just arithmetic. So for this one, I would kind of look at this 36/30, and that 36, see I said 30, so I wrote 3. The 36 I'm thinking of as 6 times 6. The 30 I'm thinking of as 6 times 5 there. And so what I'm going to do is I'm going to cancel out those 6's, and that's going to leave me 6 up top and then that 5 down below. Here I have c to the 5th up top, c to the 4th down below. So if I cancel out 4 of them, I would still have a c up top, and I have d squared up top, d below. So that's like I have d over d over d over d. So I'm canceling, and that will leave me a d. So you can write this as 6cd over 5, or the same thing is 6/5 cd, the totally equivalent. Here, I cannot cancel across addition. What I mean by that is, think about if we have 7 plus 3, or 3 plus 7 over 3 plus 2. 3 plus 7 over 3 plus 2, that would be 10 over 5, which should equal 2, right? So notice I cannot cancel those 3's. I cannot cancel something when it's being added or subtracted. I can only cancel when it's a multiplication problem. And that's why we have to rewrite all of this addition as factoring every time. So that's where reducing rational expressions, we're going to factor the numerator and denominator completely and then cancel common factors. So don't fall into the like canceling the x cubed or the x squared or something like that. So here let's factor an x out, leaving us x squared plus 6x plus 8. And here we'll factor another x out, x plus 4. Since I can see I have x times this whole thing and x times that whole thing, right there it is safe to cancel those x's. But this I need to investigate a little bit further. It's a trinomial, so we're looking for what multiplies to be 8 and adds to be 6. So plus 2 and plus 4. And now plus 4's cancel out, and then x plus 2 is our reduced form of this. So this top one is 6x squared minus 18x. So I'm going to factor out a 6x, and that is going to leave me x minus 3. The denominator is x cubed minus 9x. So I'm going to factor out an x, that's going to leave me x squared minus 9. And then this factors a little further, so let me go ahead and just rewrite this. So x plus 3 and x minus 3 from that difference of squares. And so now that I have everything factored, I'll go ahead and find the common factors. I got x minus 3's in common there, and I have x's in common there. So final for this would be that 6 is left, and then x plus 3. Okay, so then multiplication and division with algebraic fractions, it's the exact same thing we just looked at with numbers. We are going to, for multiplication, we're going to factor all the fractions completely and then cancel the common factors. And division, same thing, we'll just do the reciprocal of the second term and then multiply. So for this one, I'm going to rewrite this. And so I have a couple of different things going on. I have this division, so let me get that much rewritten right here. So I'm just going to rewrite this with this first fraction flipped over, and that'll give me a chance to write a little bigger as well. Okay, so here's what this would look like with just having taken the reciprocal of the second fraction. I'm going to rewrite this again. I'll come up here with it. So this time I'm going to kind of group my coefficients together up front here. So I'm just going to write 11 times 3, and I have x to the 11th, a to the 6th, a cubed. So that would be a to the 9th, because remember we add our exponents when we're multiplying. And I'm just kind of, this is kind of a mess, so I'm just kind of putting stuff together so I can see what I got going. Here I got 12 and 8. And then x to the 4th, x to the 6th, that will make x to the 10th, and a to the 5th. You don't have to write this step. You could just start canceling over here. And I see people mess it up because of the handwriting. So there it is, just me trying to be a little bit tidy. I notice I have 3 and 12, so I can make that a 4. And then that's it. This is an 11 up top. It doesn't work with that 32. So all I can do is go 11 over 32 in terms of the coefficients. For x, I got 11 up, I got 10 down, so canceling would leave me an x up top. I have a to the 9th up, a to the 5th down, so canceling out 5 of those would leave me a to the 4th up top. Okay, so this one's a division problem, and I think to save myself a bit of writing, I'm going to factor and flip at the same time. So for this first part, we have what multiplies to 3 and adds to be 4. That's going to be x plus 1, x plus 3. Denominator, we got multiplies to -5, adds to be -4. So that will be x minus 5 and x plus 1. And then instead of division, I'm going to rewrite it as a multiply. So this is going to be my numerator now. So multiplies to -20, adds to be -1 is going to be x minus 5 and x plus 4. And now this is in the denominator. So multiplies to 6, adds to 5. Careful with the signs and numbers on that one. That is x plus 2, x plus 3. Easy to get a 1 and 6 there with that 5 and 6 combination. Let's see what cancels. So x plus 1s are gone, x minus 5s are gone, x plus 3s are gone. And we are left with x plus 4 over x plus 2. Okay, so for this next example, they just changed the directions a little bit, but it is the exact same math. So they're giving us a couple of functions, f and g, and then asking us to multiply these. So that would look just like this, and it's the exact same factor cancel. So here we need multiplies to -15 and adds to be -2. So that will be a -5 and a +3. That's already prime, so let's write it down. That's already prime. Multiplies to 5, adds to be -6, so that's going to be a -1, -5. And let's see, so we got x minus 5, and yep, that's it. So here, I could write those side by side. I can also write them this way, x plus 3 squared, and then since these are also the same, x minus 1 squared. Okay, and now we have addition and subtraction with algebraic fractions. So same steps as we saw with basic fractions in arithmetic. We need to find a lowest common denominator, and then we're going to build each of the fractions up to that denominator by multiplying by 1. And then we add or subtract the numerators after that, and then reduce if we need to. So for this first example, we already have common denominators, so that is great. That just means we're going to add our numerators together. So let me just write out what that will look like. Okay, so this is just these stay the same as if I had, 2/7 plus 3/7 I go 2 plus 3 makes 5, 7. So we're not changing that 7. So this stays the same. And then we're just adding these terms up top. And so negative 5x plus 5x, that would be x squared. Those are canceling, minus 1 over x squared plus 4x plus 3. And then there's the fractions that we're just reducing. And so we got to check and see if it factors, and it does. X plus 1, x minus 1, multiplies to be 3, adds to be 4 is going to be x plus 1 and x plus 3. And then there's those common factors of x plus 1, and then that's going to be the reduced form of my answer. Okay, for this next one we have 9 plus 5 over 2r. So think of this 9 as being essentially over 1. And so our common denominator is just going to be the 2r. So this piece needs 2r over 2r. 2r times 9 is 18r over 2r plus 5 over 2r. And now those denominators are the same. That allows me to add the numerators. In this case, the numerators aren't like terms. So all I can do is write 18r plus 5 and then over 2r. Okay, for this next one, this one has one factor y plus 3. This one has y plus 3 squared, so 2 factors. So this one needs another factor of y plus 3. Here, let me write this in a little bit better order. This is telling us to go 6 times y plus 3, and then minus this 5 over y plus 3. Here, careful not to be tempted into canceling those y plus 3's, because that is subtraction. Remember, we can only cancel if everything is factored in multiplying. This is not factored in multiplying, so we're going to distribute and collect terms. So this is going to go 6y plus 18 minus 5 over y plus 3, and then putting those together, we'll get a 13 there. And nothing factors out of that numerator, so I'm not able to reduce it all. Okay, and then for these last couple examples, they're like the multiplication one. They're just giving this in terms of functions and asking us to add those 2 functions. So as I write this down, I'm going to factor that denominator. Multiplies to 6 and adds to be 5 is going to be x plus 2, x plus 3. And that one is plus 3 over, multiplies to 15 and adds to be 8 would be x plus 3 and x plus 5. So looking at these denominators, this one has x plus 2, x plus 3, this one has x plus 3, x plus 5. So we need to make these the same. That means this one needs this x plus 2. So we'll do x plus 2 over x plus 2 here. And then this one would need an x plus 5. And then I'll rewrite this down here as with a common denominator. Okay, so here's this written out. I just wrote it as 4x times this in an order that's a little bit easier to see the distribute. And then, oops, and I didn't actually write out that step, sorry. 3 times this x plus 2 is what would be happening there. And then that's all over the common denominator. So now we'll actually do the distributes. So we got 4x squared. 4 times 5 would give me a 20x. Right here we get a plus 3x and then plus 6. I'm going to cheat and write LCD. And then 4x squared, 20 and 3 is 23 plus 6. And that's all over that x plus 5, x plus 2, x plus 3. Okay, and then this last one is the same idea, but a subtraction. So this is asking us to do this minus this. This one is 4 over x squared minus 4 would be x plus 2 and x minus 2. Subtracting 2 over x squared plus 2x. So x squared plus 2x has a common factor of x. So that would be x plus 2. So then looking at these denominators, this one needs that x. And this one over here, this would be missing the x minus 2. So here we got 4x minus 2, x minus 2. So that's the math, 4 times x minus 2 times this stuff over x, x plus 2, and x minus 2. Again, don't get tempted into canceling there. So instead we want to distribute and collect. So 4x minus 2x minus and minus makes plus 4 over, I'm going to cheat and write LCD, which is 4x minus 2x is 2x plus 4 over the LCD. And then right here we're going to have 2x plus 2, and then over x, x plus 2, and then x minus 2. And so we do have to check when we get down to here whether or not we can factor and reduce, which is always a possibility when adding fractions. In this case, we could. So our final is going to be that 2 over x minus 2.